those who didn't do, please move to the back. Make sure you're not blocking people. But what should we be drawing? Y equals to 3. Okay, next. Draw the graph of y equals to -1. Okay. Part C. What should we draw? Y equals to x. Okay. (7b), what shall we draw? Y equals to? How do we decide? You see, I've already got a graph of y equals to x plus 3 minus 1 over x. I want to use the graph to solve this. Do they look the same currently? X plus 3 minus 1 over x. Do they look the same? Not at the moment, but I want to make them the same. So what do I have to do to make them the same? What do I need to add here? Plus 2. So if I plus 2 to the left hand side, I get x plus 3 minus 1 over x, which is what I have there already, right? Which is my graph already. But I can't just add 2 to the left hand side without changing the right hand side. So what goes to the right hand side? So this becomes 2. And this becomes now 3. So I must draw the graph of y equals to 2. Draw this. Then find the intersection. X coordinate will be the answer. Okay, the next one. What shall we draw over here? This is question 11. Draw the graph of y equals to 1. Okay. Then I believe this is the last question that I gave you. The x coordinate in part 2, where we have two graphs intersecting. Two graphs intersecting, what are we interested in? Intersection points, okay? These two graphs are 2x plus y equals to 1, as well as y equals to 1 over 6x times x squared minus 10. So these two graphs, they intersect. How do we find the values without using a graph? Simultaneous equation. This is equation number 1. This is equation number 2. Okay, so solving them, what would you like to do to solve simultaneous equation 1 and 2? Sub 1 into what? Sub 2 into 1. I think 1 into 2 is easier lah. Okay, so we have 2x plus 1 over 6x, x squared minus 10 equals to 1. This is after I sub 1 into 2. So when I solve equation 1 and 2 simultaneously, I end up with this. Graphically, if we are doing it at the same time, the points of intersection will be, the x coordinate for the points of intersection will be the solution to this equation. Okay? So now, we want to transform this equation into the form x cubed plus bx squared plus cx plus d equals to 0. Can that be done? Look at the equation I currently have. Is it a cubic equation? Yes, right. Just mentally open up the bracket. So we get 2x plus 1 over 6x cubed minus 5 over 3x minus 1 equals to 0. And then we are seeing the x cubed term appear already. And then I've also got, wait, did I make a mistake? Okay. Which part? For this question, it is about two graphs intersecting. And these two graphs are equation number 1 and equation number 2 intersecting. Graphs that intersect tells us that we should do simultaneous equation, which is what we have done over here. We sub equation 1 into 2 and we obtain this equation. Okay, now from here, we manipulate. And since the coefficient of x cubed is 1, I need to change this 1 over 6 to become 1. what shall I do? 6 drop, okay, x cubed plus 12x minus times 6, right? 10x minus 6 equals to 0. X cubed plus 2x minus 6 equals to 0. Now, what is the value of b? 0. C. D. Is this the correct answer? Okay, this here. Okay? So this type of question always done this way. Simultaneous equation. Whenever there are graphs that intersect each other. And there was also class activity number 4. To match and justify. Okay, I don't need you to match. Just tell me the equations. And let's go down the line. Let's start from the end over there. A, what's your answer? Just tell me the equation number 1 to 12. Which one is it? Yeah, this one, part A. Huh? A and C? What do you mean A and C? I'm asking you for the answer to part A. What is the equation to part A? What? Match the graphs that are similar. What do you mean you put A and C? What? To match and justify the sketches of graphs with respect to with their respective functions, right? Okay, next person. Got do or not? Did you do your work? What the equations are, and if you want me to go through anything to check your friend's answers, then you let me know, okay? Just go down the line. B, what's the equation number? What's the equation number? 10. Those who are sitting down, if you think there's a problem, you better ask, because I am not able to check right now. Next. 7. D. E. F. G. 12. H. Sharif,
For I can read
what do you have?
I wrote
2. Risi, J, K, L. Don't know how to do? Next. Next. 11. Okay, so these are the answers provided by your classmates. Do you all need me to go through any of them? Why you got 2, 2? Okay, so you are telling me that it is 4. Okay. So this should be 4. And the equation for number 4 is y equals to negative 3x. Y equals to negative 3x. Okay, this is 4. Anything else you want me to go through? K. K as well as E. Okay. For equation E, is this a familiar shape for you guys? I believe you are familiar with this shape. What is the equation like for this graph? Y equals to? Generally, what is the shape of this? What is the equation for this shape? Ax power
Negative 2.
-2. Okay, what is the relationship between what I have over here and part E? Okay, what I just drew and part E. What is the similarity that you can see? How are they related? Symmetrical about the x-axis. So it's a mirror image, right? All the y values became negative. Am I right? All the y values became negative. So that means for part E, it will have an equation like this. Y equals to negative ax power -2. So you look at the list in the next page. Apparently, there is only one. Y equals to negative ax power -2. Because all the original positive y values, they became negative now because of the -3. So that's for part E. And now for part K. Is this a familiar shape to you? It should be. I made you practice drawing this. What is the equation for this graph? Y equals to ax cubed. Okay, and now what is the relationship between k and y equals to ax cubed? Symmetrical about the y-axis. Can we also say that they are symmetrical about the x-axis? Same thing, right? In this case. So what do you think the graph for k should be like? Y equals to negative ax power 3. Okay, so we have 9. Negative ax power 3. Okay, nothing else fits. Any questions? Okay, now just want to do a quick recap on mirror image. So let's say I have the graph of y equals to 2x squared plus 3. What shape is this? What kind of graph is this? What kind of curve is this? It's a parabola opening upwards. What is the minimum point? Okay. What is the line of symmetry? Line of symmetry. Line of symmetry. X equals to 0. X equals to 0, and that is where our minimum point is found. Our parabola looks like this. Y equals to 2x squared plus 3. Okay? I want you to flip this image along the x-axis. So I want you to create a graph, or give me the equation of the graph that looks like this. So this is the graph of y equals to what? All agree with this? You understand how to do it? All we need to do is to just put a minus, and whatever is for our original y, which we have it as 2x plus 3, just put a negative sign in front. Then you will automatically flip the graph downwards already. Okay? And what is the logic behind it? Okay, let me explain over here. Suppose I have x value of 1. What is this value over here? This y value when x equals to 1? 5. Okay, 1 squared is 1 times 2 is 2 plus 3 is 5. If I put the same 1 here and I put the same 1 over here, what do you have inside the bracket? Still 5, right? But with the negative sign that is introduced, what happens to the 5? Now it becomes negative 5. So for the same 1 over here, this gives me a value of negative 5. I do the same for example, a point over here, negative 2. What is the y coordinate when I put it negative 2 inside? When I put negative 2 inside here, what is the y coordinate? Mental sums? Negative 2, 4, 8, 11. Right? So this is 11. If I put the same negative 2 inside here, what is inside my bracket? Still 11, obviously it's the same thing, right? But now I have a negative sign introduced. What happens to it now? It becomes negative 11. So over here, this will be negative 11. Whichever point I have on my graph, let's say this is x1. I don't care what it is, as long as it's x1. I put it into the equation, I will get y1. Am I right? I get a corresponding value of y. Let's call it y1. I put the same x1 inside here. What is inside my bracket? y1. When I put a negative sign outside the y1, I get negative y1. y1 and negative y1 are mirror images of each other. That's why we get a graph that is symmetrical about the x-axis whenever we put a negative sign in front of the original graph. Okay? Any questions? So how do we flip a graph from left to right along the y-axis? How do we flip? Suppose now I have a graph that looks like this. Y equals to let's call this 5. What is one possible equation for this graph? Possible equation? Give it to me in this form. X minus 1, x minus 5. Okay. What is the minimum point over here? X coordinate. 3. Good. What is the y coordinate? What is the y coordinate? How much? Negative 4. Anybody needs me to explain why or not? No? Okay, so this is the graph of y equals to x minus 1, x minus 5. I want you to flip the graph to the other side. Mirror image. So I should get a graph that looks like this, right? Right? What is the equation of this graph? Y equals to x plus 1, x plus 5, is it? Yes or no? Why no? What's wrong with this? Anything wrong?
No.
It's correct. This one is negative 1, this is negative 5. Okay? So yeah, we can write down the equation of graph, but how do I use the same method as above, where I say I just multiply a negative sign and I get a mirror image along the x-axis? How do I use the same argument for reflecting this graph left and right? Negative sign before what? What thing from positive to negative? What from positive to negative? What are you talking about? Change the 1 and 5 from negative. But what if I don't have a graph that is quadratic? What if it is y equals to, give me a moment. I want to talk about is moving a graph up and down. Y and x over here. Suppose this is the graph of y equals to x plus 2. So this is 2, right? What does the graph of y equals to x plus 1 look like?
You know that the same gradient parallel in this line intersect.
Okay, so tell me, how will you transform this, how will you move this line to give me the equation of y equals to x plus 1? Move downwards. How many units? 1 unit. Okay, very good. So you move it down by 1 unit. Okay? How do we go from this graph now to y equals to x plus 8? You move up by 6 units. Okay, this one very easy, right? How do you move the graph to the left by 1 unit? You know how to move the graph up and down. You know how to reflect the graph along the x-axis. but you don't know how to reflect along the y-axis, right? Now I ask you another question. You know how to shift this graph to the left by 2 units? When you shift to the left by 2 units, the gradient, does it change? So what is the equation? Y times 2 to x. So now I want the graph that looks like, okay, what is the x-intercept over here? -2, right? I want a graph that looks like this. Move it to the left by 2 units. Huh? Y-intercept increased by 2. So it means this becomes 4. So what is the equation now? Y equals to x plus 4. So you're telling me that shifting the graph to the left by 2 units is the same as shifting the graph upwards by 2 units, yes? Is that what you're saying? Okay. So yeah, this is one way to do it, but what if, again, now I have a parabola? Then we shift it to the left by 2 units. You understand the problem, but don't know how to do it, right? Okay, go and think about it. So we have talked about shifting up, down. We talked about reflecting. How about stretching? We also can stretch a graph, right? Okay. Yeah, okay, but let's talk about y equals to x squared. This is the graph of y equals to x squared. Give me a quadratic equation for a graph that looks like this. The one in red. This one. Y equals to? No, x squared minus 1 will be shifting the graph down by 1 unit. 2x squared. So you are introducing a different coefficient. Let's see if it works. Let's say this is 1 over here. Then according to my original equation, it should be 1 also, right? 1 square is still 1. But for my equation in red, 1 square is 1 times 2, you get 2. So is this a possible equation? In red, 2x squared, yes? What have we done? We introduced a coefficient that is greater than 1. And what effect does it have on the graph? You compress it this way, right? You compress it along the x direction. Alternatively, can I describe it as stretching it in the vertical direction? Is it the same? Why not? See, for the same x equals to 1, original value was y equal to 1, right? I am now pulling it up to y equals to 2. Every single point is now stretched upwards to get a different point. So instead of saying it is compressed horizontally, I can say it is stretched vertically also. Now give me a suggestion for this blue graph. Okay, half x squared. Possible? Yes. So how do we describe this transformation? Stretch horizontally, or we can say that we compress it vertically. Okay? This is useful for all types of graph. Let's see whether we can do it for straight lines. This is the graph of y equals to x. If I want to compress it vertically, I should get a graph that looks like this, right? What is one possible equation for this graph? Y equals to half x. And now use your knowledge of gradient. Talk to me about the coefficient of x. The gradient is less than 1 as compared to the original gradient, which is 1, right? So it is less steep. Does it make sense now? Okay, let's stretch it vertically. We stretch it vertically, we should get something like this. Okay, yeah, it could be y equals to 3x, for example. The gradient is steeper. We are stretching it. Then, let's say I want you to draw the graph of y equals to negative 3x. What will you do now? Draw downwards. So it is a mirror reflection of which line? Y equals to 3x. So reflect it, you get this. Y equals to negative 3x. If I want to draw the graph of y equals to negative 3x plus 2, what will you draw? What will you do? Move which graph up? Y equals negative 3x, you move it up by how many units? 2 units, yes. So this is graph of y equals to negative 3x plus 2. Same method can be used for our quadratic graphs, cubic graph, any graph. These are the steps to transformation. By transformation, we have translation. That means moving them up, down, left, right. We have reflection, reflect about different lines. We have stretching, scale factor, stretch and compress. Okay, less than 1, compress. More than 1, stretch. Any questions?
So what are these?
Later when you do trigo graph, you will be using them. Okay, next on gradient of curve. Let's look at example number 12. Constant speed, but the question didn't give you speed. So you're telling me that you covered this in physics? Right? Kinematics, right? So the gradient of our distance time graph gives us the speed. What is the gradient from A to B? Can find or cannot find? Can find. So it is, rise over run, and we see that the gradient is constant, implying that the speed is constant. What happens from B to C? How do you know it is at rest? Gradient is equal to 0. Can you tell based on the distance also? Did the distance change? So it must be at? So it must be at rest. Okay, next one. From C to D. What is happening over here? The gradient is increasing, therefore the speed is increasing, therefore there is an acceleration. The speed is increasing, so there is an acceleration. Is it uniform acceleration? No? Don't know? Or what?
Yes and no. From 3 to 4 is no.
From 3 to 4? What 3 to 4? My question is the acceleration uniform? The answer is, I don't know. Until you can give me the graph of velocity versus time. Okay? So this is what is happening over here. Okay, next thing. How do we find the average speed for the journey? Total distance divided by total time. What's the total distance?
60.
Total time? Okay, good. Simple or not? Okay, what is the speed at time equals to 3? Speed at time equals to 3 hours. 32?
34.
So what's the speed? 11? How do you get 11? Huh? Speed equals to 32 divided by 3.
Speed is the gradient.
Divided by 4. 24. 34. Why? Wait, what kind of formula is this? Oh, distance divided by time. When you learn this, distance divided by time equals speed.
Everyone.
Where did you learn this from?
Primary school.
Primary school? Yeah, your primary school only deal with constant speed. Your primary school only deal with constant speed. So yeah, you can use this in primary school. Now you're not in primary school. You're in secondary school. This is still applicable if I have constant speed. Which part of the graph has constant speed? Yeah, so we can use distance divided by time for this. We also can use it for BC because it is a constant speed of 0. Now from C to D, is this still constant speed? No, then you cannot use it anymore. What do you mean by total speed? Average speed. I can ask you average speed by time equals to 3 hours, but that is not my question. My question is, what is the speed at time equals to 3 hours? So yes, the speed is given by gradient of distance time graph. And what is the gradient at time equals to 3? Where is the gradient? Darius, you gotta stand.
3 bracket.
Now.
3
So how do I find the gradient at time equals to 3?
equation.
I'm not gonna use an equation. Tangent line. Can you draw a tangent line? Use your graph right now, ruler, pencil, draw a tangent line at time equals to 3. You will accept a range of values, but if it is obviously wrong, then it will be out of my range already lah. So something like this is obviously acceptable. This is acceptable. What is not acceptable will be something like this. Okay, this tangent line over here appears to be for this timing, 2 point something. Okay, I need you to channel your inner artist out.
Artist.
Yeah, because it's drawing. So once we have the tangent line, then you can find the speed. Understand?
I didn't take out for this so
So what is the speed at time equals to 2? So all agree that it's 0? Time equals to 2? It is not moving? Speed is 0? Any other answers besides 0? 15. Why 15? Huh?
Wait, so can you say question again?
30 divided by 2.
No, can you say question again?
The question is, what is the speed at time equals to 2 hours? So I've got an answer 0 because it is at rest. I've got an answer 15 because 30 divided by 2 is 15. Then how? Which one is correct? Okay, you all ready for the answer?
Yes.
The answer is, it's undefined. It's undefined because you think about what is happening to this object. Let's say it is a ball. Okay? Let's say it is a piece of glass. Let's say it's a piece of ice sliding across an icy surface. So no friction now, okay? So it's sliding at a constant speed. Can you imagine? Suddenly stop. How does it suddenly stop? When will it suddenly stop? When it hits something, right? Yeah, friction is negligible. When it suddenly hits something, then it will stop, right? So at that point of impact, what is the speed? Just before it was 15. Just after the impact, it was 0. In reality, right, everything will take time to stop. Things don't just instantaneously stop. For example, when you're running. You're running at a constant speed. I ask you to stop. Can you stop immediately? No, right? You have to slow down, right? You have to decelerate first. Yeah, depending on how fast you are. So, in reality, we don't just stop when we say stop. We will always, as we are running, we always have a speed. Just that the speed will slowly slow down, otherwise known as deceleration. There will be deceleration until we come to a complete stop. Which is what I'm trying to tell you over here. This graph is not realistic at all. Because of that sharp point over here. This point is not realistic. Because you should be able to tell the speed of every single object at any point in time. Okay? So a more realistic graph will look like this. Straight line, then a curve, then a curve again. Get it? Whenever you draw distance time graph, I expect it to be smooth. Okay? Unless the graph is given to you already, then you just use it.
So in
Okay.
this graph, the cyclist is at uneven speeds.
Okay, next. Okay, let's just discuss this question. Try 12. This person running 100-meter race. What can you tell me about the motion from A to B? Constant what? Constant speed. Is it possible or not? Is it possible for somebody at the start to go at this constant speed? Possible, right? Possible, but what is more realistic is that he will slowly increase the speed, right? Because he will accelerate until he goes to a maximum speed, maybe something like this. Then after that, he will dash through at his maximum speed. But this guy is very strange. His strategy is very strange. He starts at a constant speed, then towards the end, then he speeds up. I think what is more normal is that at the start, you already start to accelerate, then you accelerate at your maximum speed. Huh? Yeah, so this person a bit strange, okay? Now, what is the total distance covered? What's the total distance covered? 100. 100 meter race, what? What's the time taken? Can find average speed, yes? Can find instantaneous speed. Instantaneous speed means the speed at any point in time. Do you realize that instantaneous speed and average speed are different? Okay, so what is the speed from A to B? Constant, okay, this is 64. 64 divided by 10. 6.4 meters per second. Okay, 6.4 meters per second. What happens from B to C? What happened to the speed? Increase or decrease? Increase, right? So he is accelerating. If I want the speed at this point, what will you do? Draw a tangent line. Then find the gradient of tangent line to give us the speed, yes? What then is the speed at C? What does your tangent line look like? Based on this graph, the tangent line at C appears to be a vertical line, right? What is its speed? Undefined, it is super steep, right? So, although we say undefined, we say it is infinity. Oh, he run at infinity speed. Not be lah, right? So it cannot look like this. Okay, I'm just nitpicking on the graph. But I just want you to be able to appreciate what all the different parts of the graph means, okay? So this one not very realistic. Why is it infinity? Because the gradient over here is infinite. What is more realistic is that the graph, okay, if you want to increase at the end also can lah. But it stops here. Then this is our final speed. Something like this is more realistic. Okay, at least there's a speed as compared to infinite speed, which doesn't make sense at all.
His speed suddenly increased so much. Acceleration like so high.
Okay, next. So earlier on I mentioned that distance time graph, right, is supposed to be smooth. But if I really want to force a situation out where it is not smooth like this point over here, it is also possible if I am, for example, walking. So I walk at a constant speed. Realistic, right? I walk at a constant speed. But I say stop, and I just stop here. So my speed from constant became 0. And then I change direction. Go back to the original point. So the distance over here from P increases from 0 to 800. Then after that, the distance becomes 0 again. Can you understand what's happening? Yeah, you turn back. One more time, I'm starting from O right now, which is P lah, okay? What? I am starting from P, I am walking a distance away at a constant speed. Now look at this part where I say stop. So I'm walking, then I say stop. Actually, I'm still decelerating, agree? I'm still decelerating for a bit only, but because I'm walking so slowly, right, you can't really see it. So my point still stands that it shouldn't be a sharp point over there. It should be a bit of a curve, but never mind. Okay, let's just pretend that I really from constant speed, I stop immediately. And then I turn back. But this time my speed is lower. I'm taking a longer time to complete from 800 back to 0 meters. Understand what's happening now? So is there any part of the graph that you need me to go through? No, Can the graph go this way? Can or not? Can. Why? Can the graph go below the x-axis, the time axis? Why cannot? Yeah, distance must be positive only. But what if I change the question to displacement? Then can lah, okay? the distance from P. Isn't the distance from P the same thing as? Of 80 meters per minute from Q to P. So instead of starting from P, right, you start from Q straight away. Where is Q? Q is 800 meters away, right? Okay, so he must start from 800 meters away. Okay, that's for Jackie. His starting point will be 800 meters away, somewhere along the green line. But what time did he start?
5 minutes.
Or 5 minutes later. Okay, so this is the starting point, starting time. That's 1 point already. And since he's working at a constant speed of 80 meters per minute, I have the gradient. So it will be sloping downwards because I start from the 800 meters away, I hit drag to point P. Now, draw the distance time graph. Where and when did they meet? So it's quite a simple scenario. As such, the graph is given already. Where and when did they meet? M? Point M? What's so special about point M?
They meet each other.
Yeah, okay, they meet each other, but why are you so sure that they met each other at point M? Yeah, they intersect at the same point, right? At this point, right? So this tells me that for Jackie, when time equals to 7.5, he was 600 meters away from P, the origin, right? So for Jackie first at 7.5 minutes, he was 600 meters away from point P. For this girl, Betty, at the same 7.5 minutes, she's also 600 meters away from point P. Doesn't that mean that they were at the same place at the same time?
Yes.
That's it, that's how they meet. Okay, so whatever I told you is still the same. Every time you have two graphs on the same grid, the points of intersection confirm significant. It will mean something. Darius, you woke up already? Yes? Yes, you know. Okay, have you been exposed to this type of graph before?
Yes.
Have you seen this before?
Teleportation.
I hate this so much.
Okay, teleportation. Yeah, that's quite a good way of describing it.
I didn't even draw the graph.
So here we have the speed, right? The speed for Betty, initially it was 80 meters per second. 80 what meters per minute. Okay, then at time equals to 10, the speed was 40 meters per minute.
Impossible, she just suddenly scroll.
Exactly my point. It's impossible for her to suddenly, from 80 meters, suddenly change to 40 meters per minute. You get it? In reality, you don't do that. You always need to take a bit of time to slow down and to change direction. Get it? But for this ideal case, we're going to do it like this. So, based on the graph, what is the speed at time equals to 10 minutes? Based on this graph, what is the speed at time equals to 10 minutes?
You cannot tell whether it's 50 or 40.
I should hear answers like either 80 or 40. Right? But in this case, there's only one answer. Which one is it?
40.
How do you choose 40? Based on the graph. The one that is colored. Just like our inequalities, right? Whatever we circle is the one we want. The hollow circle is excluding. Understand?
So they draw graph like this.
Yes, you may be asked to draw graphs like this. Although it's quite rare. Can?
So why don't they just draw like that?
Same thing. Okay, now, just discussion for these two graphs for two different people. Where and when did they meet? Oh, wait. Can I tell from here? No, I can't tell from here. Okay, I gave the answer away already. Okay, so this is the speed time graph. What can you tell me from a speed time graph? Acceleration. How do we tell acceleration from a speed time graph? Gradient. So for A, this person is traveling at a constant acceleration. So you see the graph, the speed time graph is linear and it is increasing. Okay, constant gradient. So constant acceleration over here. What about for B? Tell me about this speed. Is it increasing?
Decreasing.
Is the speed increasing?
Yes. Basically.
Yes, the speed is increasing. At a decreasing rate. Okay, yes, you are right. The speed is increasing at a decreasing rate. Okay, you see the speed really increase, right? The value of the speed goes higher and higher. But the rate in this case refers to our gradient, which is our tangent line. Imagine all the tangent line over here. So it's steep or not?
Yes.
So the acceleration is high or low?
High.
Okay. As we move, what happens to the gradient?
Less steep.
Less steep means the acceleration is
Lower.
lower. Yes, you're right. So it is increasing but at a decreasing rate. Okay? That is for acceleration from a speed time graph. What else can we generate from the speed time graph? One more thing. What else can we get from the speed time graph besides acceleration? Distance travel. Where is the distance travel? Area under the graph. Okay? Do you know how to calculate area under A?
Yes.
Do you know how to calculate area under B?
No.
Not yet. Next time you will learn. Okay? So if I ask you all next time after O-level A-Maths question, where and when did they meet? Where and when did they meet? What would you like to find out? Area under the graph. Okay? So suppose we choose time equals to 10. Can you find the area under this graph? Yes, right. Then next time after you learn this thing called integration, you will be able to find the area under this blue graph. As long as the areas are the same, that means what? They meet because the distance traveled is the same at the same time. Understand? So this is the logic of how we are going to calculate next time. Okay, so same thing over here. Okay, last type of question. Water tanks. Water tank, So, class. A and B, the dimensions are in meters. These are uniform cross sections. So they are prisms because they have uniform cross section. Water is poured into the tanks at a constant rate. Let us talk about tank B first. Okay, start off empty. Water being poured in at a constant rate. So do you expect the height to increase at a constant rate?
Yes.
For B at the start.
No.
Yes.
At the start. So let's simplify things. Let's say tank B, right, looks like this. Okay. We chop off the top. Okay, let's call it tank C. Tank C over here. I pour water in at a constant rate. Do you think water level will rise at a constant rate?
Yes.
Okay, you're right. It will rise at a constant rate. Because the amount of water going in is fixed at a fixed rate. Then the cross-sectional area is the same. So it is the case of your water bottle if it is a perfect cylinder. Look at your water bottles. If it is transparent, then all the better. Then you imagine you go to the water cooler, you turn it on, full blast. So the water rate coming out is constant, right? Then your water level will be rising at a constant rate. But what happens when you have a water bottle that looks, for example, like this one? What happens if your water bottle looks like this? So when you turn on the water cooler, the water level rises up, right? Constant, right? But what happens when it comes to this one? Faster or slower? Faster. Why? Because the cross-sectional area is smaller, the volume over here is smaller. The water going in is still at the same rate. It doesn't care. The water tank doesn't care about your shape. Your water level will rise at a constant rate, then it will suddenly shoot up. Then after that it will slow down again. Okay? So for bottles that look like anybody using those mineral water bottle? Mineral, let me mineral water. Okay, this one. For mineral bottle, you fill up the water, then you can turn to your friend and chit chat, right? Then water go out, right? Then when it's coming to this part already, you must look back again because it will quickly rise up, isn't it? Because the area here very small, the cross-sectional area is very small. Okay. Thank you. So now, tank plus. For tank B, let's talk about the rise, the increase in the water level. At the start, okay, at the start, it should be rising at a constant rate, yes? So suppose this is the rate. So now the depth is 1 meter. Okay, what happens after this point in time? After the water reaches this part, does the rate increase or decrease? Decrease. So it should be steeper or gentler? Gentler. It takes a longer time. Okay, understand how this works? Okay, then another type of question. What if the water tank looks like this?
It will go slower.
Okay, so let's say the initial rate is 10 liters per 10 meters per minute, for example, the rate of increase of height. Do you expect the rate to drop or rise? Drop. So it will be faster and faster or slower and slower? Slower. Okay, so for this one, at the start, it will be fast, right? Something like this at the start. Then we expect the rate of increase to rise or drop again? Drop. So it should look something like this, right? Because it's less steep, Then after that, what happens? Constant? When will it ever be constant?
And one after one.
After 1. Okay, but let's say before it reaches 1. So we expect the water level to increase at a higher or slower rate? Always slower and slower, right? Until we reach the point 1. So it's something like this. Then you are telling me that when the depth is equals to 1, they will be at a constant rate. Okay, this is at height equals to 1, height per meter. Because after I reach the depth of 1, there should be constant rate already, so this part should be a straight line. Agree?
Yeah.
But this part, I have 3 straight lines. The reason I came up with these lines was because I thought about the starting rate, then after some time the rate drop, right? Then the rate drop again, right? In reality, is it going to happen like this?
Curve.
What is the reality going to look like? Curve. What does the curve look like?
Like something like this. Like, there's no edges.
So the curve
Something like this.
should have this shape. Get it? Okay, let me exaggerate a bit more. Okay, class, this part. Here we have a curve. At the start, the rate is high. Okay, it is steep. Then it gets less and less steep, but the water level is still increasing. Until this point, it will be constant. Understand? I have one important point to make. You are expected to be able to draw this, and if your drawing looks like this, cannot. Why cannot?
Because it's like
Can define the gradient here or not? Can you draw a tangent line here?
no.
Cannot. It is a point. It is a sharp point like that. So cannot. It must be smooth. It must be smooth. Okay. Similarly, I cannot have it looking like this. Understand? Okay, that's all I have for today's lesson. For your test, at least.